viewers, today I am going to explain some more subtopics of chapter Electrostatics. Our subtopic is Gauss law. Before starting the topic, first of all, I want to give you this example as you are seeing in this diagram. In this diagram, we have four charges: Q1, Q2, Q3, Q4. These four charges has been enclosed in an arbitrary shape object. As I have told you that the total amount of the flux on the surface of the object does not depend upon the shape of the object. The total amount of the flux is equal to the Q with a charge, which is a charge enclosed by the object, upon epsilon naught. Now here we have four charges that have been enclosed in an arbitrary shape object. Now let's find out the total flux on the surface. The total flux is equal to flux 1, which is due to the charge Q1, plus flux 2, which is due to the charge Q2, plus flux 3, which is due to the charge Q3, plus flux n, which is due to the charge Qn. Okay. For example, n amount of the charges are enclosed in the arbitrary shape object. Now we will put these values. Total flux is equal to, we know that flux 1, which is due to the Q1, so it will become Q1 upon epsilon naught, plus flux 2, which is equal to Q2 upon epsilon naught, plus Q3 upon epsilon naught, plus Qn upon epsilon naught. Now as we know that epsilon naught is same, so we will take common 1 upon epsilon naught. So total flux is equal to 1 upon epsilon naught, round bracket, charge Q1 plus Q2 plus Q3 plus Qn. Now we can write it as total flux is equal to 1 upon epsilon naught, round bracket, total charge enclosed by the surface. Now this sum of the charges Q1 plus Q2 plus Q3 plus Qn is equal to capital Q. So the total flux, which is equal to 1 upon epsilon times multiply the total charge enclosed by the closed arbitrary shape object. So this formula, we have derived a formula, and this formula is known as Gauss law. Now let's read this formula. The total flux on the surface of the object is equal to 1 upon epsilon naught times in multiplication, 1 upon epsilon naught times of total charge enclosed by the object. Now let's see the statement of Gauss law. The total flux through any closed surface is 1 upon epsilon naught times the total charge enclosed in it. Now see the formula that we have derived. Now here, the total flux through the surface is equal to 1 upon epsilon naught times in multiplication, Q means the total charge enclosed by the surface. So this formula is known as the Gauss law. The total flux through the surface is equal to the 1 upon epsilon naught times the total charge enclosed by the surface. So this is known as Gauss law. Now let's see the application, first application of the Gauss law. Here we are going to find out the intensity of the field inside the charged hollow sphere. Okay, here we have a hollow sphere whose outer surface is charged. Okay, now here we have selected an imaginary surface which is represented by the dotted line, an imaginary hollow sphere which is represented by the dotted line inside the charge sphere, and this imaginary hollow sphere is known as Gaussian sphere. Gaussian means imaginary. And now we are going to find out the intensity on the surface of this hollow sphere, on the surface of this imaginary sphere. Now, in order to find out the intensity on the surface of this Gaussian sphere, first of all, we will find out the flux through this Gaussian surface. Now, the formula of flux is equal to Q upon epsilon naught. Now, Q is the charge enclosed by the surface. Now, here, there is no charge enclosed by this Gaussian surface. So, here, we have Q is equal to 0. And if Q is equal to 0, then the total flux through the Gaussian surface is also equal to 0. Now, as we know that the flux is equal to 0. Now, put the another one formula of flux. We know that flux is the dot product of the electric field intensity and the area. Now, put the value of flux. So, it will become, if flux is equal to 0, it means the dot product of the electric field intensity and the area is equal to 0. Now, since we have selected the Gaussian sphere, so it has some area. The area is not equal to 0. The area is not equal to 0. We know that the product of the electric field intensity and the area is equal to 0. It means there is a single quantity between this electric field intensity and the area which is equal to 0. Since we have selected the Gaussian surface, so area will not equal to 0. It means the value of the electric field intensity is equal to 0. Therefore, its product 0 dot A which is equal to 0. So, here we have concluded that the electric field intensity inside the charged hollow sphere is equal to 0. So, with the help of the Gauss law, we have got the result that the electric field intensity on the Gaussian surface, or we can say that the electric field intensity inside the charged hollow sphere is equal to 0. Now, let's see the another one application of the Gauss law, which is electric field intensity due to an infinite sheet of charge. We have a infinite sheet of charge, okay, in which we have selected a hollow cylindrical Gaussian surface. This is a hollow cylindrical Gaussian surface which has two ends. This is circular end 1 and this is circular end 2. The electric field lines are emitted from this circular end and from this circular end. And A is the area of this circular end. Now, we are going to find out the total flux. Again, we will apply the Gauss law. We know that Gauss law, the total flux. So, there are two flux. The first flux through this surface, circular surface, and the flux through this circular surface. Okay. The flux through the wall of this cylinder is equal to 0. Okay. So, we have a flux through this circular surface and the flux through this circular surface. So, we have two flux. And we know that the total flux through the surface, which is flux 1 plus flux 2, is equal to 1 upon epsilon naught times the total charge enclosed by the surface. Okay. So, flux 1 plus flux 2 is equal to 1 upon epsilon naught times the total charge enclosed by the surface. Okay. Now, there is a formula of the charge density. Sigma represents the charge density. Charge density is equal to total charge divided by area of the surface. Solve it by cross multiplication. So, total charge is equal to charge density multiplied by area. So, we can write it as charge density multiplied by area in place of this total charge. So it will become flux 1 plus flux 2 is equal to 1 upon epsilon naught time the product of the charge density and the area of the surface. Now, put the value. We know that the flux 1, which is equal to intensity multiplied by area, okay, these are the magnitude, and flux 2 is equal to intensity multiplied by area. Now add these two values. It will become 2 EA plus EA, which is equal to 2 EA, which is equal to 1 upon epsilon naught times the charge density multiplied by area. Okay, the area, these two areas will be cancelled. These two areas will be cancelled. So it will become intensity E is equal to sigma upon 2 epsilon naught, and R represent the unit vector, okay, which represent the direction of the intensity. Now, see the third application of the Gauss law. In this topic, we will find the intensity of the electric field in between the two oppositely charged plates. Now here we have the two oppositely charged plate, positively charged plate and the negatively charged plate. And the electric field lines, we know that which starts from positive plate and terminate at negative plate. These are the electric line of forces. Now in between the plates, we have selected a Gaussian hollow box, or I can say that we have selected an imaginary, Gaussian means imaginary hollow box in between the plates. One side of the box lies in the positively charged metal plates, while the other side, three sides, lies in between the positively and negatively charged plate. Now the side S2 and S4, since the side S2 and S4 are parallel to the electric field lines, so here in these two sides S2 and S4, the total flux is equal to 0. Now here we have this first side S1, whose surface is perpendicular to the electric field lines. Now here we can find out the flux. Okay. Now the flux through the side S1, which is equal to 1 upon epsilon naught times the total charge. The total charge is the product of the sigma and the area of the surface S1. Now the flux is equal to intensity multiplied by area. Okay. The flux is equal to E dot A, which is equal to magnitude of the intensity multiplied by magnitude of the area multiplied by cos 0, and cos 0 is equal to 1. So E multiplied by A, which is equal to epsilon naught times the charge density multiplied by area. So intensity, so area will be cancelled at both sides. So intensity is equal to sigma upon epsilon naught, where R is the unit vector which represents the direction of the intensity. So this is the third application of the Gauss law.